Any doubt? Last class?
No, sir. Not sir.
Okay. So we'll do the. I have some assignment that is common for the both universities. So I will do the numericals. Consider the question is given here. Is given 1 upon 1 by 1 upon 1 square plus 1 plus 2 divided by 1 square plus 2 square plus 1 plus 2 plus 3, 1 square plus 2 square plus 3 square, and so on. Okay, so what we can write the nth term here? So see here, so first term is here 1 upon 1 square. Second term is 1 plus 2 and that square also is given. Third term is similarly 1, 2, 3, 1 square plus 2 square plus 3 square. Similarly here next term will be 1, 2, 3, 4, right? Divided by 1 square plus 2 square plus 3 square plus 4 square. Similarly if you write the nth terms, it will be 1 plus 2 plus 3 and so on up to the nth term. And the denominator will be 1 square plus 2 square, 3 square, and so on up to the n square, right? So this one is the sum of n natural number, right? Sum of n natural number, I have told you the formula n into n plus 1 by 2. And sum of n square formula is n into n plus 1, 2n plus 1 by 6. This one I have taught both in the first class. Sorry? Any doubt? N into n plus 1 by 2 divided by 1 square plus 2 square. This one is given. This one I can write it. This formula. N into n plus 1, 2n plus 1 upon 6. Right? Yes, sir. So if you simplify here, so this part it will go cancel here. It's 6 by 2, this is 3, and it will come in the numerator 3 upon 2n plus 1. Any doubt till here?
Sir, right? Denominator 6 for
formula is there, no? Formula this one.
Formula?
This is formula I have taught in the first class. This is in the 12th was there. Sum of n natural number, sum of a square of natural number. Sum of n natural means 1 plus 2 plus 3 and so on up to the n. And this is square means 1 square plus 2 square, 3 square up to the n square. So if you want to consider, if you want to add up to the 3 terms. So what is the value here? 3 square is 9 plus 4 plus 1. That should be 14, right?
Yeah.
That 14, if n is equal to 3, if you put it here, you will get it 14 only. So 3, this is 4, and this 3 to the 6 plus 1, 7. 7 by 6. So this is 2 and this is 2. We are getting the 14 only. So this is the formula only. This is already we are studying the POC, the 12th class. Okay, so I have substituted here. We got the value of an is equal to 3 upon 2n plus 1. Okay?
Yes, sir.
Okay. So now we can do it with method. N is something like 3 upon 2n plus.
Comparison method.
Yeah, comparison will be fine here. So b of n, yeah, you can write common here. 3 upon n is common, 2 plus 1 by n. Right? So bn you can choose it 1 upon n. So an upon bn, yeah, un by bn is equal to limit of n tends to infinity. The 3 upon n into 2 plus 1 by n divided by 1 by n, which is come to the reciprocal here. And this part and this part
No,
is
we
get
want to
cancelled.
eliminate 3, right? So what if we 3 by n?
Sorry?
Yeah.
3 by?
Sir, I really can't hear it.
Tell me.
Bn shouldn't it be 3 by n because we want to eliminate 3 also.
No, so no take. Because I told you, no, this have to take in the maximum power. Okay, if you want to take n by 3, like 3 by n, you can take it, no problems. That is not any difference here. But 3 is the constant here. It's not any n here, so you have to not check out the variable how much is the maximum power. That to divide it.
Okay.
Because this is 3 is the constant here, so you have to not worry about that constant part.
Okay, so it's okay if I remove it also.
If you want, if you will take here 3 by n, right? So again it will come n by 3 and cancel it.
Yeah.
But here 1 by n to the power p is there, then we can write p series. P series, the statement is there, is not like that something should be numerator, right?
Yeah.
So better you don't take only, because the rule is you have to follow, like the constant part you have to not worry about. Okay, in doubt here?
No.
So here this part I cancel here, so limit of n tends to infinity, this is 0, so we got it 3 by 2, which not equal to 0, not equal to infinity. So means we can, that comparison test is successful, right? So b of n is equal to 1 by n, and here p is equal to 1, right? That power is here, nothing is there, means 1 is there, right? So p is equal to 1 means that is divergence. B of n is divergence by p test. So we can write a of n is also divergence by comparison test. Getting?
Yes, sir. Yeah.
Next question, if you given summation of 1 upon n sine of 1 by n. This one. This is the n is equal to given. Okay. So tell me which method you can do it. n is just leave it summation here. Given sine of 1 by n upon n. Which method you can apply here? Integrals, okay. Next, p test we cannot do. Comparison test.
P test we can do.
P test we can do not do because 1 by n power p should be there. So we'll try. Let's try comparison test. And if you limit, if you know that basic I have taught in the last class, limit of x tends to 0, sine of x by x. Limit of x tends to 0, x by sine of x.
Yeah, it's 1.
Okay, all value is what? 1 only, right?
Yeah.
Tan of x by x, and limit of x tends to 0, x by tan x. Only for this, not cos. Okay, and only when x tends to 0, then only it will be 1.
Yeah.
But we are putting the values is infinity because the limit we are finding at infinity only, right? So here I can write it like b of n is equal to, put it here, 1 by n square. Why I decided n square here? If one n, if we to get cancel here, still one n will be there. That's why.
Sir, can you repeat?
See here, if I want this format, right?
Not. Can you hear him exactly?
I can hear you.
So I can't actually hear you correctly. At all, there's a lot of disturbance. So.
Some noise is coming as well.
Yeah, there's a noise. Yeah, now it's fine.
Now it's fine. See here, we know that this one property is here, so we want to bring it this x, okay, and this x should be the same. Then value we know that equal to 1 when limit x tends to 0, right? Sin of x by x, limit x tends to 0, value is equal to 1. Okay, so here is given sin of 1 by n divided by n. If I will take it 1 by n square here, so actually I will multiply with n square and this part will get cancelled, right?
Hello?
Yeah. Hello?
Yes, sir.
So an is equal to sin of 1 by n divided by n. So bn, if I will choose it n here, only bn is equal to 1 by n. So it will get cancelled, right? An by bn, if I will write it here, I will write it sin of 1 by n into n. And bn is 1 by n, so it will cancel here. So that's why I am substituting the values is 1 by n square, so still 1 n will be there. If n square, if I put it here, still after cancel 1 n will be there, and I can bring it this n in the denominator, right?
Okay.
Getting?
So what's the purpose for it? Like.
So I can do the comparison test.
Okay.
I'm doing the comparison test here, and so I can bring it this format, and I can use these properties. Yeah, I can solve it like by using the comparison test. So if b of n is equal to 1 by n, I will take here, it will not work.
Okay, yeah, it will get cancelled.
It's cancelled.
1 is left. Okay.
So if I will do it now, an by bn, so sin of 1 by n divided by this n, and bn is 1 by n square will come to the numerator, right?
Yes, sir.
This and this part is cancelled, so still 1 n is there. So an by bn is equal to, I can write n into sin of 1 by n.
Yes.
Limit of n tends to infinity, right? Now this n, I can bring it in the denominator like this.
Yeah.
And out
Then
here.
it will get 1. Yeah.
So here not 0, then only it will be 1. I told you now only.
Okay, infinity.
Here infinity is there. So directly we write not it's wrong. You have to put it here. 1 by n is equal to, let's consider some t.
Okay.
So 1 by n is t here. So if n tends to infinity, t also tends to what? 0 only, because 1 by n is given, right? If n tends to infinity, t tends to 0.
Yeah.
So I can write it here in the term of t. T tends to 0. Sin of that 1 by n is t divided by t. Okay?
Okay.
So now the value is equal to, this is 1. And 1, which means not equal to 0, not equal to infinity. So it's satisfying the Cauchy's proof test, right? The comparison test.
Yeah. Okay.
So now we have to check out the value of b of n. B of n is 1 by n square. So p is equal to 2 here, 2 is greater than 1, then is convergent by p test. So we can write here a of n is also convergent. And doubt till there?
No. No.
A square root of n plus 1 minus a square root of n is a of n. This one already told here. What you have to do? You have to do the rationalize, right?
Rationalizing.
Rationalize means negative part you take as a
Denominator.
So a of n is equal to given here root over n plus 1 minus root n divided by, we can write it here, root over n plus 1 plus root of n divided by root over n plus 1 plus root n. Okay. So this is a plus b. This is a totally, a minus b and a plus b. So we can write here a square minus b square, right? A plus b into a minus b is a square minus b square. So here this one whole square becomes n plus 1 because the square root is finished, minus n divided by a square root of, that is square root of n plus 1 and plus root n. So this part get cancelled here, 1 upon root over n plus 1 plus root n. Now we can do by the comparison test.
Yes, sir.
Any doubt?
So can we put directly the infinity in n?
Infinity if you put, then you can put it, because here,
Then it will be 1 by 2 now.
but nothing,
If we
but,
put infinity.
but here nothing is there to cancel it, right?
1 by 1. Okay.
No, you can't put it, because if you put it here, this become infinity plus 1.
So it will be 1 by infinity 0 then.
Okay, so it's become an indeterminate form. Okay,
Yeah.
so I will, shall I do it? Yeah, can you do it?
So you solve it.
Okay. So I can check here outside here. First, let me check out how much the maximum power is there, right? So in the square root, if I'm doing a step by step. So 1 plus 1 by n,
Plus 1 by
root over n, right? So 1 upon, this one is just like a root over ab. I can write root over a into root over b, right? So root over n into root over 1 plus 1 by n plus root n. Getting? And also I can write it after that 1 upon root n common here. So the square root of 1 plus 1 by n plus 1. Getting?
Yes, sir. Yeah.
So now b of n. B of n is equal to how much you have to choose? This one.
And
1 by root n. So a of n by b of n is equal to limit of n tends to infinity. You can write 1 upon root over n times 1 plus 1 by n plus 1 into root over n.
and get cancelled.
Root and get cancelled. So infinity if substitute, this 1 by infinity is 0. So this is 1 plus 0 is 1 and plus 1. That become 2. So 1 by 2. Right?
Yes.
So 1 by 2 is not 0, not infinity. So we can check b of n, which is
0.
n of half. So p is equal to half, which is less than 1.
Less than 1.
So it's divergent by p test. So I can write that a of n is also divergent by p test. Any doubt in this?
A of n is also divergent by comparison.
Comparison test.
Yeah.
Similarly, one question was also there in the assignment, that n power 4 plus 1, the square root of n power 4 plus 1 minus the square root of n power 4 minus 1. So this one also you have to do with the same method. Okay, rationalize it and cross multiply, that you do same procedure. Okay, it will come long here because b of n is not we cannot substitute the b of n also, because in the numerator it's coming in, right?
Yeah.
We cannot substitute it here. Okay, so this is sorry. This is.
So it will get cancelled there.
Sorry.
Yeah. So in that step, if it's cube, then should just get cancelled over.
It will be cancelled. Okay.
Yeah. Okay.
So that cube root of n cube plus 1 minus n. So a minus b, this one is there. A minus b is equal to a cube minus b cube.
So you can just continue from there. So you don't have to do the work.
Just I will do it. First I will finish it. Okay. So here this one is a cube. So I can write it here n cube minus 1 minus b cube is n cube, right?
Yeah.
Divided by a square, which means this one is a whole square, n cube plus 1 to the power of 2 by 3 plus ab. Ab means n times of n cube plus 1 to the power of 1 by 3, and b square is n square. Any doubt in here? Anyone?
No. No.
So here if you take the common here, this part and this part is cancelled here. So actually this is minus 1.
Okay.
So minus 1 divided by here power is n power 3 outside.
Minus 1 plus 1.
Okay, this is plus 1 is given, so plus 1. This is plus. So n to the power 3 if you take outside here, 1 plus 1 by n, right?
Yes, sir.
That power of 2 by 3. And here if you taking whole outside, that become n only.
Yeah,
Just I am writing just as it is. One step because it will take n into, here I am taking n cube outside. So it will become 1 plus 1 by n to the power of 1 by 3, right? Plus n square.
So 1 plus 1 by n cube, right?
Sorry?
1 plus 1 by n cube, the next term.
This is 2 by 3 for the overall. This is, okay, I will write it here only, that power of all. Now is correct, no? Now is correct because I written in the bracket.
Yeah. Yeah.
So 1 upon, this one is outside, if you take it become n square. 1 plus 1 by n cube to the power of 2 by 3, right? Because if you take outside, this 3 and 3 get cancelled. Here if you take outside this one here, so here here I taken the common was this one, n cube was there, no? So this and this will get cancelled here. This 3 and 3 get cancelled here, n will be remaining, n comes outside, n square. Any doubt in this?
No.
N square, now we can write it here. This is as it is only remaining, 1 plus 1 by n cube to the power 2 by 3 plus 1 plus 1 by n to the power 1 by 3 plus 1. Any doubt? Now this is an is here, so p of n is equal to write 1 by n square. Okay, and you can check out an by bn, it will not come. Infinity will not come 0. Okay, so b of n you can check here 1 by n square, which is p is equal to 2 and 2 is greater than 1, so it's convergent. So a of n is also convergent. Well, wrong question, that's why it's
I have a question, can you solve that?
yeah, tell me.
1 by 2 plus 1 by 5 plus 1 by 10. It goes on like this.
1 by 2
plus 1 by 5 plus 1 by 10.
1 plus 1 by 5 plus is given.
Plus, yeah, 1 plus 1 by 2 plus 1 by 5 plus 1 by 10.
1 by 10.
It goes on like this, and the n term is 1 upon 1 plus n square.
1 upon 1 plus n square.
Yeah.
So what is the doubt here? This is already easy, no? This is. So here n term already given here.
Yeah.
This is what who is asking this one?
The comparison test is okay, fine.
No, this is easy. No, this is so just without by seeing you can do it. That n square you take outside. P is 2.
Okay. Yeah. Yeah. Fine.
Next, I will do it from the Cauchy's and D-almbert method. Some questions. Then I will go to the alternative series. See here, this one how you do it. Tell me which method you apply here. Is given here 1 factorial divided by 1 square plus 2 factorial divided by 2 square plus 3 factorial divided by 3 cubes and so on. Tell me the nth term.
N factorial by n square. Yeah.
N factorial by n square. N square. Okay.
N plus 1 by 2.
This is 1 square, 2 square, 3 square. No, here is going to keep increasing here. 1 square, 2 square, 3 this 3 cube. 4 factorial divided by that 4 to the power of 4 and so on and so on.
So it should be 1 to the power 1, right? So it will be n to the power n.
Yeah. N factorial divided by n to the power of.
So it's not 1 square, right? It's 1 power 1. The first term.
1 power 1. 1 given also, yeah, square given also is fine only because we know that the value is 1 only, right? Because 1 square also if you given here, we can take as a 1 only because this power is what actually 1. Actually 1 is given here, no problem. Okay. So because if you put it n power n, you can check out. Always I told here when you find the n term, you put it and check out your n term is correct or not. Put it n is equal to 3. You should get this one. 3 you put 3 factorial in the numerator and 3 to the power 3 is correct. Okay. So now you tell me which method you have to apply. Which method will do? Is comparison it will work?
No.
P-test?
Not P-test.
So P-test fell here, comparison test fell here, then another we have which one? Cauchy's, right?
Yeah,
Cauchy's is what? If you given n, then power you can take 1 by n. So if you power, if you take sorry.
Power 1 by 2. No? It's 1 by n only.
1 by n Cauchy's root test. Cauchy's root test power of 1 by n.
Okay.
So here power of 1 by n if you take that will be long questions only because n factorial to the power n factorial also is very large function. Okay. The highest this largest function is n factorial only because this is n factorial means keep multiplying here. Okay. So here complexity is more. Okay. And if you take 1 by n here, again it will become increasing. And if you take 1 by n also, it will not help anything to simplify. So this Cauchy's method also is what fail only. So here we will do it by using the D-almbert test. Okay, D-almbert test I have explained, right? So what is the D-almbert means? You have to find the next terms divided by u of n terms, right? Limit of n tends to infinity, and if you got it L is less than, then convergence, L is greater than, then divergence, and if L is equal to 1, test fail, right?
Comparison.
Then use the comparison test. So here you tell me the next terms will be what, and I told here telling here once again, whenever the factorial kinds of thing is there, which is recursive functions, we have to use D-almbert test. When the exponential is
What
given,
was that?
so factorial here given, factorial is repeated functions, okay? Like 5 factorial, I can write 5 into 4 factorial, right?
Yeah.
So this is repeating itself here. So that type of, if a given series here, so that time use the that D-almbert. When the exponential question is given like 2 to the power x, yeah, some a to the power of x, okay? So this is power is given here, that time you use the Cauchy's root test.
Okay.
So now here you can find the next terms, n plus 1 term. Tell me that n plus 1 factorial divided by n plus 1, n plus 1. Now you can write this one here, a of n plus 1 divided by a of n, limit of n tends to infinity. So limit of n tends to infinity here, n plus 1 factorial divided by n plus 1 to the power of n plus 1 into, because if I write here this one divided by, so it will go up, right? So n factorial will be here and n to the power of n it will go in the numerator. Any doubt in here?
No.
Any doubt?
So what did you do in the last step?
Nothing, I did bn and write it here. No, bn is what? N factorial by n to the power n. So this will go up here.
Yeah.
So now try to simplify this one and find the limit. So here n plus 1 factorial, I can write n plus 1 times n factorial. Like 5 factorial, n factorial means n into n minus 1 factorial, right? So n plus 1 is given here, so I can write keep decreasing 1. So n plus 1 as it is into n factorial, right?
Okay, yeah.
Divided by, this one is as it is, you write it because this one you cannot do anything, into n to the power of n divided by n factorial. So these factorial things, this is cancelled, right? Any doubt in this?
Okay.
And one more thing we can cancel it here. N plus 1 to the n plus 1 is given, this is n power n here. I can write this one as a n plus 1 into n plus 1 to the power of n. I can write it?
Yeah.
Because just like a power m plus 1 given. So a power m into a. So I can write limit of n tends to infinity, n to the power of n divided by n plus 1 to the power of n. So I can take the maximum power outside here. This is n power n, and here if you take n power n common here, so we'll get 1 plus 1 by n to the power of n. Getting?
Yes, sir.
So this part is cancelled here. So here limit of n tends to infinity, 1 upon 1 plus 1 by n to the power of that n. So here you tell me what you do now after that.
Substitute limit for n.
So see here, if you put the values here, if this power is not there, you can substitute it.
Yeah.
If only the limit of 1 plus 1 by n will be there, then I can put it limit of n tends to infinity, that 1 by 1 plus 0 is 1. Okay?
We'll go for P series.
Sorry?
1 plus 1 by n, we have that P series, no?
No, that P series how? P series only n power P should be there.
No, then cauchy.
Cauchy is,
right? It's just an are 1 by n, so n can.
yeah, that we can do it. That part is okay, fine. But we have already started this one with the D-almbert test, right? So if this one is what already started, if test this one fails, then another you can do it. Between that, what you do? 1 to the power of n. Again, you have to find the limit only then. If you do it 1 to the power n also, then again you have to find the limit only.
Yeah, but then n would have gotten cancelled, so it would be 1 plus 1 by n limit.
But the Cauchy is not as telling here anywhere you can apply. Okay, this is an is given, an is a particular value is given, then you can apply the limit here and you can do it 1 by n. This is not the particular value only, no. Getting why if given here only is that 1 by 1 plus 1 to the power n in the question. Okay, then you can do it cauchy or whatever you do. But here already limit n tends to infinity. This is not particular value, still we didn't get the constant values. This is limit. Limit means still we don't know whether it is continuous or discontinuous. If limit exists, then it's continuous. Sorry?
So we have the formula
yeah.
We can exaggerate now, so 1 by n minus 1 by
so this one formula is there. Okay. This one formula is there. Limit of n tends to infinity, that 1 plus 1 by n to the power of n. This one. That value is equal to e. That e value is 2.71. Okay. Getting?
Yeah. Yes,
so this is the limit property is there. This one you keep in mind if you don't know. So because this directly I will show you where it is, that formula. When we study the first chapter stabilities, then I will teach you that limit things. Okay, this one is formula. Keep in mind. Keep in mind now. N tends to infinity. 1 plus 1 by n is equal to e. So here what will you get here?
1 by e.
So here is one, actually is not given. This one is 1 by is given. 1 divided by this one is given, right?
Yeah.
So we can write it. What is the values? 1 by e.
1 by e.
So 1 by e means 1 upon that e value is 2.71. So we'll get it.
Something.
We'll get it less than 1.
Yeah, fine.
That 0 point something 3 will come there.
Yeah.
That is less than 1, right?
Yeah.
Less than 1 means that should be
convergent.
That should be convergent.
Convergent
by D-almbert test only. Okay, any doubt in this? This one more question is here. 1 plus that alpha plus 1 divided by beta plus 1 plus alpha plus 1 2 alpha plus 1 by beta plus 1 times 2 beta plus 1 plus alpha plus 1 2 alpha plus 1 3 alpha plus 1 divided by beta plus 1 beta 2 beta plus 1 and 3 beta plus 1 and so on is given. Okay? So tell me the end term here.
So 1 plus n alpha plus 1 upon beta plus 1
alpha plus that
2 beta n beta plus 1.
Yeah, good. 2 alpha plus 1 3 alpha plus 1 and so on it will come to the finally is finally will be n alpha, right? N alpha plus 1 divided by beta plus 1 2 beta plus 1 3 beta plus 1 and so on, that n beta plus 1. Okay.
So where did the 1 go?
This one.
Yeah.
This is the first term only, no? This one first terms.
Okay.
So here we have.
We don't write.
We will not, because you can ignore here because It's keep increasing here. So if you know the series, this one what it's going on, plus 1 will be the same.
Okay.
Because if you're coming, like consider this value is 0. Yeah, some particular value. So particular value means convergence, right?
Yeah.
Some particular value with 1 if you add it, still will be some values only, right?
Yeah. Oh, yeah. Oh, in the end, you just add the 1.
So here this one is the, now which method you can apply here? See here I told here whenever the repeated something is given, apply the D-almbert. So you can, so many terms you can cancel it, that's why. So n plus 1 is equal to what will be the same thing, alpha plus 1, 2 alpha plus 1 and so on. Last will be n alpha plus 1 and this will be n plus 1 times alpha plus 1, right? Divided by beta plus 1, 2 beta plus 1 and so on. This is n beta plus 1.
So you can't use that formula for the epsilon n is n plus n into n plus 1 by 2.
That one. That plus is not given overall, no? That series is not given. Plus is not given in between that here, no? That is formula for when the series is given a plus 2d. Okay, like that. N by 2 into 2a plus n minus 2. Sum of sum of AP is given, then we can do it. They are already given n term, we are finding just this one natural number. First term will be this one here, second term will be this up to the here, third term is up to the here, n term up to the here, n plus 1 to the here. So now you tell me if you do un plus 1 divided by un, what will you get? This one will come in the numerator, right? I am not writing here, here only I will cancel it. This one will come in the denominator. So if you divide this one divided by this here, so numerator is this. So this part will get cancelled here. Yeah. And here this part will get cancelled. Right? So n plus 1 means this. How? Like here even by
everything to be n plus 1.
See here, I will do it.
We just multiply x plus 1
alpha plus 1, 2 alpha plus 1 and so on. N alpha plus 1 and n plus 1 alpha plus 1, right? This is the beta plus 1, 2 beta plus 1. This is n beta plus 1 and n plus 1 beta plus 1. This is the un plus 1 term, right?
You take n plus 1 alpha plus 1 just common from the whole n plus 1.
No, nothing common. See, I'll do it. I'm doing here. This is the un plus 1 term, right? Divided by un term. Un term means this one divided by, like, if you write alpha plus 1 divided by beta plus 1. So beta plus 1 part will go up, right? So beta plus 1, 2 beta plus 1 and so on till the n beta plus 1. And here alpha plus 1, 2 alpha plus 1 and so on n alpha plus 1. So now this is all the multiplication only, so you can cancel it this part to this part till here.
Okay.
And this part is n term up to the here. Any doubt? So now limit of n tends to infinity, u of n plus 1 by u of n is equal to remaining term is n, this one, n plus 1 alpha plus 1 divided by n plus 1 beta plus 1. So here what you can take common, n plus 1 directly take the common, don't multiply. So here we will get it to alpha
plus 1 upon
n plus 1. If you multiply also you can take it, okay? N plus 1, and this is beta plus 1 by n plus 1. So this one is cancelled here, we will get it here, this is 0. So alpha by beta.
Yeah.
Any doubt till here? So we got it, limit of n tends to infinity, u of n plus 1 by u of n, that is equal to alpha by beta. Okay.
Yeah.
So if alpha by beta, this alpha by beta is equal to 1. Yeah, first let's consider less than or greater than values. That if less than 1.
How do you know the value of alpha and beta?
We don't know the values, just we are writing the test now. That D-almbert test, we know that, right? It's less than 1, then it's convergence, right? That less than 1 is convergence. So we can write here this u of n which is given in the questions will be convergence if alpha is less than beta.
Yeah.
Okay. Similarly, we know that alpha by beta, if greater than 1, then it's divergent. So alpha by beta means alpha is greater than beta.
Okay. So what about that 1 at the beginning of the question? Can we add it here? Should we make it alpha by beta plus 1?
Alpha plus beta plus 1, huh? Yeah, that also will be the same thing only. No problem. Okay, will be the same only, okay? 1 plus alpha is equal to that will be the same one. If alpha is equal to 1, then test fail.
Yeah.
So alpha is equal to 1, then test will be failed here. So you correct here the alpha. See, we getting sorry. You are not alpha is equal to 1 actually. Sorry. Alpha by beta is equal to 1, then test fail.
Yeah.
Okay. So alpha is equal to beta, then test fail. So we can find it here. What will happen here? Limit of n tends to infinity. Alpha and beta both are same. Both are same means let's consider this is both are some values, right? X. So will be 1 here. Limit of n tends to infinity of 1 is equal to what? 1 only. So 1 is coming into the convergence here. Because 1 is the constant value here. Okay. So this is, you can write here alpha is equal to beta, then is alpha is equal to beta, then a of n is convergence by limit test. You can write this is the limit I did know. This is limit test called as. This is the basic one. So overall an I can write it here. Alpha is equal to beta, then it's convergent. Alpha greater than beta, then it's divergent. Any doubt in this? This equal to symbol has come in the convergence because we have done in the limit here and we got the constant values that 1.
So we did the D-almbert test, right?
D-almbert test.
Then we wrote a limit test in the end.
No, I'm not getting. You don't know the D-almbert test?
Yeah, I know that. We wrote convergent by limit test. No, if it is alpha is equal to beta, then the test fails, then the comparison limit test is reduced.
Till here you can write by using the.
Got it.
This one is by using the D-almbert test, but after that has come in the that limit this one.
Got
it. Any new questions you have? Now everything almost have done it.
One question. In that assignment which I given, and that the fifth one, that assignment, the fifth one, the C part, C and the E. Just do the E part. So that is 1 by n divided by ln.
Summation of n is equal to 3 to infinity. Before that I will teach this one also, okay? Because I have both I still have not taught that integral test. Okay? So integral test I will finish it then, because these questions last class we have done one integral question, but that I have not taught still. Okay? Integral test. Let's consider a of n be a sequence of positive numbers. Yeah, positive terms here. And first we have to check out here conditions here, that which positive terms, and suppose that series a of n is equal to f of n. Yeah, f of function n, and f of n is continuous. First condition should be f of n should be the continuous.
Okay.
Continuous positive. And second is decreasing function of x. Decreasing function of x for all x is greater than equal to n. N is a positive integer. Then if this condition 2 holds, then we can write here then the series summation of n is equal to n2 till the infinity, that a of n, and the integral that infinity to n's to infinity f of x dx, both convergence or both divergence. Getting there?
Okay.
So here that so if this one value is coming to the infinity, then it divergence, means if we're finding the integrations. If we're getting the infinity, then it divergence. If we're getting some constant value, then it convergence. What we can do by the method, this one is the integration method. Getting? And integration method only we can apply here, this integral test, when we know that that function is continuous and decreasing function. Okay? So like I will take the example simple, then I will do the one questions which you have said. F of x is equal to given summation n is equal to 1 to infinity here given. And that 1 by n. So if you put it here, 1 plus 1 by 2 plus 1 by 3, like that one is given, right? So this one is series given. Already we know that this one you can do by the p-test also. What is the p-test here? 1 by n power p is here. P is 1 here. P is equal to 1 means divergent. So already we know that. But now we are doing by this integral method. And it should come same only. So this one first condition we check out here, that this is continuous. This is the continuous function. This is continuous here because 1 by n, 1 by 2, 1 by 3, whatever the value is given, always will be continuous. Why continuous here? Because 1 by n value is given here. From minus infinity to infinity, any value you can put it here, except this one 0, because 1 by 0 will be infinity, right?
Yeah.
So here from the 0 we have to checking it here. But the question which is given here, n is equal to 1 to infinity. You have to not think about the 0 and all. Right? The limit is given for us for 1, n is equal to 1 to infinity. From 1 to infinity, whatever the value you put it, you will never get discontinuous, right? You will get 1 if you put 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on, 1 by 1000, and it will become continuous. So, we know that this f of n is continuous.
Okay.
Now it's decreasing function. This is decreasing function, yes. Decreasing only because first value is 1. After that 1 plus 1 by 2. It's 1 by 2 decreasing here. 1 by 3 is decreasing and so on. 1 by 1000, 1 by 10,000, it will keep decreasing on. So it's decreasing also. So both conditions, 1 minute. So both conditions are hold. 1 minute. So you can say that here. Any doubt till here?
No, sir. No.
So f of n is here continuous and decreasing also. Okay. So now we can apply this integral formulas to check whether this function is convergent or divergence. Okay, so this both conditions holds. So we can integrate here whatever the limit is given in the question, that is 1 to infinity. That 1 by that x, yet n you write whatever. 1 by x integration is ln of x. That is equal to that 1 to infinity. Limit of n tends to infinity, ln of x minus limit of n tends to that 1, n या x whatever you want, write it, that x. So infinity we put, then this value is what? Infinity. Minus, if 1 you put, then 1. So infinity minus 1 is infinity, so it's coming to the divergent. Getting? So divergent means this value is what? This p by the p test also we know that this is divergent. This method you can do by the.
So you put 1 by x because n term is 1 by n.
Yeah. This is 1 by x, and limit is up to the whatever the question is. I will do one more simple question, then I will take your questions that which you have mentioned. Here is given here this u of n is equal to 1 upon n log of n to the power of p. This one. So here first p series and all you can't apply cauchys you can do for this one here, but what will you do in the log? Okay, so this log is not constant here, right? Because n is there. If constant is there, then you can eliminate and you can apply the p test. If the question is given like this here, log of e to the power p. So e is what here? Constant here, right? Yeah, log of some value is given. This is a constant here. You can do directly by the p test. But this method, this one n is there here, we cannot apply the p test. Clear? Comparison we cannot do it, because if you cancel it 1 by n, you can cancel it, but still not log of n will be there, right? Another D-almberts and all. We'll see. You can do it another method also, but now we are targeting here to do by the integral test.
Okay.
So is it this function is decreasing function? Yes, because 1 by n is given. So 1 by n, if you keep increasing the n, it will decreasing only, right? So now after that, yeah, if you do this function is continuous, because you can write it here to this logarithmic functions, and this n is what? Algebraic functions, right?
Yeah.
1 by n is algebraic. Both are always continuous in its domain. Whatever the domain will be there, it will be continuous.
Okay.
But we have to check.
We have like one statement for that, right?
Sorry.
Just one statement for that.
Yeah.
Both going to be continuous.
Yeah. You can write it. Now after that, we have to check whether it's decreasing or not, because directly we cannot say that this is decreasing. 1 by n, I know that, but maybe n is what? If reciprocal value will be there, 1 by 2, so it will come up only, right? 1 by n is there, but n is equal to, if it comes, n is 1 by 2, so 1 by 2, which is 2, it will come. So maybe increasing also. In this case, last case, we know that is 1 by x only is there, and n is what? Tending to 1 to infinity here, can't be 1 by 2. Because 1, 2, 3, 4 and so on it will be there, but here is limit is not given, so it might be that less than values also, right? A fraction value also. Getting here? So we'll prove it by using, we know that in the 12th class already we started given differentiation, you find it. Differentiation you find it f dash of x, and f dash of x is what? Less than 0, then it's decreasing, and f dash of x is greater than 0, then it's increasing, right? So we'll find it that better I will write this f of x in the term of x only, that x log of x to the power of p. Okay, so f of x is equal to 1 by x, and this one I can write log of x to the power of minus p. Can I write it?
So what you do here is differential.
It should be identity differentiate. I just written in the term of x. So our differentiation will be easy because always we learn from differentiation.
Why is that minus p to the power?
Because I taken numerator.
Denominator. Okay,
So numerator if I am taking here, then I can apply u into v, right? Differentiation.
Okay, got it.
So f dash of x is equal to u into v. So I can write u as a 1 by x.
Yeah.
And this one differentiation. Tell me differentiation for this one. Minus p into log of x of minus p minus 1, right? Into 1 by x.
Yeah.
Chain rule. X to the power n differentiation, that is n into x to the power of n minus 1. And then inside differentiation, log differentiation is 1 by x. U into dv by dx plus v. V means log of x to the power of minus p as it is only. And 1 by x differentiation is minus 1 by x. So if you take it here, this is also 1 by x square, right? This is also 1 by x square. So minus 1 by x square I am taking outside here. So I will get it 1 upon log of x to the power of this part first, p. And this one I can write p divided by log of x to the power of p plus 1. This one. Now if you can say here, okay, this is x here. Okay. And now x, all value of x is what? In the denominator here. And whatever the value which will come here, if this minus is there, here the confusion was there here. If n is fraction, then it will become positive, right? Like n is equal to 1 by 2 is there, become 2. Here if you 1 by 2 also, there is minus symbol is there. So it will always will be what? Decreasing only. Getting?
Yeah.
So you can write here f of s is decreasing function. Any doubt in there? So this one. Sorry. I will send you that same notes. I will send you.
Yeah. So unit differentiated because x was not defined.
Right? Yeah. So here we have done here. This one is just for the checking. This is decreasing or not. Okay. Still this question is integral test is not started. This is just checking for the decreasing. So complex question is there, then you can do by the integral test. Okay. And integral test is actually easy if you know the differentiation and integrations. Okay.
So do we have to prove all this?
Sorry.
Do we have to prove all these things?
Prove
like
means?
When we, it's like is it continuous or
yeah.
decreasing?
You have to prove it.
Okay.
Without then every questions you can apply integration and make it easy. Okay, so here is you have to show that this condition if it holds, then only you can apply integral test. So you have to show that no, this both condition is holding. Okay, next. See here, given x is equal to here 1, 2, whatever the values is given here, we have to substitute it here and you have to take it here, these values. So this function is a decreasing function, we got it here. Now her limit, we'll assume it has some functions. Where is the question was there? This one only, right? So see here, now this function is decreasing or fine here. If x is, we know that if the value of x which is given here, that should be less than 0. So here, this question now we can write it here. This is when 1 will be there, value is what? Log of 1 by 1. Log 1 is 0, right? And this is power p is given. So we can take as the limit from that summation of x is equal to 2 to till the infinity. Getting? So 2 to infinity it becomes here 1 upon n log of n to the power of p. So we can integrate here because already we know that this is continuous also and decreasing also. So f of x which is 1 by x This is log of that x to the power of p. Okay, and dx. So log of x is equal to, I will consider as a t. 1 by x I will consider as a dt.
So how do you take from 2 to infinity?
Because here the 1 here, if we write it 1 also here, because 1 value is coming 0 here, right? Infinity here it's getting.
Yeah, okay. So from 2 on.
2 onwards. So here you can write here dt is equal to dx. That dx is equal to x into dt, right? So I will write it here 2 to infinity. That 1 by x as it is only. This is 1 by this is t to the power of p, and dx is equal to x into dt. This one cancel here. So this will be 2 to infinity t to the power of minus p and dt. So t to the power minus p plus 1 by minus p plus 1, and that is 2 to infinity. Okay. So if you put it here, 1 by 1 minus p is anyways outside here. So limit of this one I can write it. This values t to the power of minus p plus 1 from 2 to infinity. Right?
Yeah.
Now here only I will do it. Yeah, I will do it here. One upon 1 minus p. See here, first condition is what here? P should be not equal to 1, right?
Yes.
T power minus p plus 1 divided by 2 to infinity. This condition only holds when p should be not equal to 1. P equal 1, then 1 minus 1 is undefined, right?
Yes, sir.
So p should be not equal to 1. So what will be the case here? Case may be p is greater than 1. So p is greater than 1 means that 1 minus p is what? Less than 0. Because 1 minus p will be less than 0, because this p value is greater than 1. So it will give negative value only, no?
Yes, sir.
Understanding? Think about here, 1 minus p, and p if we increase like 2, 3, 4, 5. So this will become negative value only, no? 1 minus negative value. Negative value means less than 0. So let's consider this value is equal to p. Okay? So I can write here this integral of 2 to infinity f of x is equal to t to the power of minus k by minus k. Okay? This value I put it here, 1 minus p is some constant k. Any doubt in this? That is called 2 to infinity here. You can put the infinity value, 1 minus k outside here. Infinity if you put, this becomes 0. Infinity this because this power is minus, right? Infinity power minus k. Minus 2 to the power of minus k.
So, by minus k, it will be k only, right?
This is minus 1, no? That's why.
Why will it be minus k? But it's minus p plus 1. So it's equal to k. It's 1 minus p is equal to k.
See here, 1 minus p is less than 0, right? That equal to I consider as a k. K is any positive values here. So if you put it here, this one here, so 1 by 1 minus p. This become how much? This k is negative only, right? So this will be here 1 by 1 minus p is negative here. This become positive. Not getting? See here. Still here in doubt? Till here is fine? Let's consider some value only better. It will be easy for you to understand. 1 by 1 minus p is what? That less than 0, right? 1 by 1 minus p is less than
Yeah.
0. Less than 0 means some negative value, right? Negative 5, negative 6. So that's why I am considering this k, and k is a negative value. Okay.
Okay, so value is negative, so you're taking minus.
Yeah. So 1 by 1 minus p. That directly, now I will write it better. 1 of 1, this one is less than 0. 1 minus p is less than 0. So this is negative values. Okay. Into t to the power of minus p plus 1, again this one also is negative values only. Minus k. 2 to infinity. Any doubt?
No, sir.
So I can write minus 1 by k here. If we infinity we put, then infinity to the power of minus k. And this is 2 to the power of minus k. So minus 1 by k here. And this is infinity to the power of negative, anything comes 0. And this is 2 pi over minus k means 1 by 2 to the power of k. Which means 1 by k into 2 to the power of k. Okay? And k is a what? Some negative values only. So we'll get the finite values only. Getting? Finite value means negative or positive, whatever. That is convergent. When is p is greater than 1. Similarly, we will be convergent also when p is less than equal to 1. Why? Because p less than 1, if you put it here, you can check out here. P less than 1 if you put here. So there is what? 1 minus, let's consider 0.5. Okay? If 1 minus p, I am putting it here less than 1. Means less than 1 means some decimal values, right? That value is equal to k.
Okay.
That 1 minus p will be positive numbers here. Right? Positive. Tell me. Any doubt, then you tell me. Otherwise, I can't move.
So, how is it positive this time?
No. Here I case I taken here 1 minus p. P when greater than 0. Now I am taking the case p less than 0. Now you think here less than 1 means what? Yeah. So 1 minus p less than 1 means 0.5. 1 minus 0.5 will be some constant value, positive value.
Got it.
So here if you take 2 to infinity here, nothing will change here. Here it will come 2 to the power k. And it will come here 1 by k times 2 to the power of k after overall. So this is also giving the finite value only, right?
Yeah.
So we can write this is convergent only. So we can write that question which was given, a of n is convergent by integral test. Any doubt in this? Next question is, the question which you have given, which one? Question number?
5.
That 1 by n upon that ln of n divided by a square root of that ln square of n minus 1, and this is given 3 to infinity. So this is the continuous. We can write here this is f of n is continuous, because logarithmic function always will be continuous on its domain. Okay. And if you want to check out for the decreasing function, again you can do by the differentiation and you can check out. Okay, directly I am doing the integral test. 3 to infinity 1 by n. I will write better in term of x. One by x divided by ln of x into a square root of ln square of x minus 1. This one, how will you do the integrations? Ln of x is equal to consider as a some t. So then 1 by x is equal to dt by dx, right? But if you take also, we won't cancel anything. L of n here x, if you taking here t, so t is equal to 1 by x, dx is equal to, it's become is 3 to infinity. Okay, let's consider. So here I will write it here 1 by x as it is only, log of n is t. This is square root of t square minus 1. And this dx is equal to, I can write it here, x into dt, right? X into dt. This x and this x cancel, right? So the remaining is here 3 to infinity. To infinity 1 divided by that t square root of t square minus 1 dt. Okay. Any doubt till here? So now this one integrations already we know that this one we can integrate it, right? How to integrate this one? That is this one directly. If you know the formula, that second value will be there. You know this one in the 12th class was there. This in the 12th class, that one if you put it here, t is equal to do it better. To infinity plus t. This is x square minus 1. So I can write t is equal to here tan theta. Okay. So dt is equal to secant theta into d theta. Right?
Yeah.
Secant square theta minus tan square theta, we know that is equal to 1, right? So tan square theta plus, if you take here 1 of it, second you consider. Okay, this one up. Second you have to consider, because we want to bring here secant square theta minus 1. T is equal to, put it here sec theta. Okay. So sec theta dt by dx. Sec theta is equal to, what is the formula? Differentiation sec theta into tan theta, right? So dt is equal to right here sec theta into tan theta dx. Any doubt till here?
No.
Just I differentiated here, nothing. So I'll substitute here. So t is equal to, I put it here sec theta, so I'll write this one here. This one is a square root of secant square theta minus 1, and this is in the place of dt. I can write this one. Okay, secant theta into tan theta. Okay, this is a theta actually. Okay. So now here secant square theta minus 1 is equal to 3 to infinity 1 by sec theta, and this one I can write here secant square theta minus 1 is equal to tan square theta, right? So I can write only the square root tan theta, and that is secant theta into tan theta into d theta.
Tan square theta, right?
The square root is there, no? So this one is 3 to infinity. This is only 1 d theta. So one integration is theta, right? So we have assumed here t is equal to sec theta, so theta is equal to sec inverse of t. Theta is equal to sec inverse of t. 3 to infinity. Any doubt in this? And now t is what? This one also is there, okay? C is what? ln of x. Ln of x. That is equal to 3 to infinity. So we will put it here, limit of n tends to infinity, sec inverse of ln of x minus limit of n tends to 3, sec inverse of ln of x. Ln is equal to what here? We will get it here to infinity if you put it in this. That becomes here pi by 2. Okay, that 90 degree. Infinity only, no? That infinity minus this one is ln of 3. If you put it, you get it here sec inverse of ln of 3. Any doubt in this? This one is sec inverse. If you put it here, then you get it values is that infinity, right? Sec inverse infinity is pi by 2. That values is pi by 2, because sec you can write here also. Sec theta is equal to what? 1 by cos theta. Getting? Any doubt in this? So this is a. So we got the values is what here? Pi by 2 minus secant inverse of pi by 3. Means this is some constant values, right? So this is convergent only. This will become a little long question is there, but it's fine. Okay, any doubt in this question? For checking the discontinuous, you can differentiate and you can do it. Will be decreasing only. Okay, if the question is given, always will decrease. Just to find it f dash of x and so that is less than 0. Okay, so we complete till here.